The stem and leaf diagram. The stem and leaf diagram will be illustrated by means of an example. Example A. Let's say we were trying to predict the number of customers our restaurant would serve over the course of a 30-day month. We collected daily data for a similar period last month and saw the following number of customers daily. In its current form, the data does not reveal much about the performance of the restaurant over a 30-day period. It would be difficult for us to make any effective conclusions from the data without any clear visual representation of these numbers. Let's arrange the numbers in such a way as to paint a more visual picture of the dataset. Representing the data in the form of a stem and leaf diagram would yield the following. In this form, the first digit of each number corresponds to the row in which it is placed. For example, the numbers 40, 42, and 45 would be placed in the 4 row, and then only the last digit would be written down in that row. So this would yield 4/0250, and this would be interpreted as the first number being 40, the second number being 42, the third 45, and the fourth 40, and so on. After writing the numbers in this form, one would then need to arrange the digits in each row in ascending order. As a final step, you would need to include a key in order to ensure that someone else would be able to interpret the numbers in the diagram correctly. So in this case, 3/0 would be interpreted as the number 30. When the numbers are displayed in this format, it is much easier to get an idea of how the restaurant performed last month. We can see that most days averaged between 20 and 39 customers. Few days saw outliers with regards to customers, so only 2 days had a large number of customers, with 2 days having fewer than 10 customers. The highest number of customers seen per day was 54, and the lowest number of customers seen was 2. Another useful feature of stem and leaf diagrams is that they allow one to make comparisons between two datasets very easily. For example, after management instituted a new marketing strategy, the number of customers per day was recorded. What conclusions can we come to? Again, we have a dataset that's raw, and we now plot the results of the 2 years side by side, and we can see the following. Before the marketing strategy would be shown on the left, and after the marketing strategy would be shown on the right. Here our key can be interpreted as follows. We can see that the 1 lies in between 2 dashes. So the number 0, or the digit 0, corresponds to the number 10 on the left-hand side of the 1. And the number 6 on the right-hand side of the 1 corresponds to the number 16. We can make a few observations from the stem and leaf diagram above. Visually, it can be seen that before the marketing campaign was instituted, the number of customers seen was relatively balanced, with a majority of days seeing between 20 and 39 customers per day. After the marketing campaign, the number of customers seen was skewed towards seeing 30 or more customers every day. Before the marketing campaign, the restaurant had a fairly high number of days where it saw very few customers, under 20. After the marketing campaign, the number of days where the restaurant was relatively empty had dramatically decreased. After the marketing campaign, we can see that it is most likely that the restaurant would see a range of customers between 40 to 49 on any given day, as opposed to between 20 and 39 customers previously. The most customers seen in a day before the campaign was 54, whereas after the campaign, the restaurant saw a record 59 customers during one day of the month. We can conclude that the marketing strategy has generated more customers on average for the restaurant per month, and has therefore been effective.